Today, we can see how to transmit audio wirelessly using light. This technology is known as LIFI. It was first introduced by Harold Haas during 2011 TED Global Talk. LIFI is a wireless communication technology which utilizes light to transmit data. LIFI sounds similar to Wi-Fi. The difference is that Wi-Fi uses radio waves to transmit information. The Wi-Fi has comparatively longer range than LIFI. The range of Wi-Fi is about 150 feet indoor and 300 feet outdoors, but LiFi has a range of approximately 10 meters. But the range can be further increased up to 100 meters using lasers. It consists of two units, the transmitter and the receiver. Using light as the medium, the transmitter sends an analog signal. The receiver unit consists of photosensitive element like photodiode, LDR, etc. The receiving unit is connected to the device to which the data is transferred. When the light falls, the photosensitive element in the device detects the change in amplitude or brightness of the light and sends it to the microprocessor for further processing. For the transmitter part, we need a signal source. Here we are transmitting audio signal, hence I am using a Bluetooth speaker for that. Then we need an output device that transmits the information. Normally in LiFi, LED lights are used, but I am going to use laser since it has a good range. The wires to the speaker from the Bluetooth module is cut off and connected to the signal and ground pins of the laser module. Now if we play an audio, the laser glows with varying brightness according to the magnitude of the audio. But the brightness is too low. That is, the laser module is not getting enough power from the Bluetooth module. Hence we need to add an amplifier to amplify the weak signal. I am going to use BC547 transistor as amplifier. How this works is, if we apply a weak signal to the base, we will get an amplified signal across the emitter and the collector. In other words, the resistance across the emitter and collector changes in accordance with the base voltage. After using the amplifier, the brightness of the laser diode has increased. That's all for the transmitter unit. Now coming to the receiving unit, we need a sensing element to sense the varying amplitude of the laser beam. Here I am using a laser receiver or laser sensor for that. You can also use a solar panel for that, but the laser sensor produces better output than the solar panels. It has 3 pins, the signal, 5 volt and ground. If we connect the signal and ground pins to the terminals of a speaker, we can hear an extremely mild music. But it is not enough. Now connect a 5 volt source to the 5 volt and ground pin of the sensor. Now we can hear the audio. But still the volume is not up to the level and is full of unwanted noises. So I have used the same BC547 transistor amplifier to increase the volume. Now we get acceptable performance. Then I increase the distance between the transmitter and the receiver. It works up to 100 meters with acceptable performance. With the increase in distance, the laser beam becomes wider, hence the intensity decreases and the sound quality also decreases with the increase in noise level. That's all for this video. I hope you have learned something new and don't forget to hit the subscribe button.